Hi physics students. In this video, we want to try to figure out what it means to talk about the direction of the acceleration. It turns out the direction of the acceleration can tell us something about an object's motion, but it's not immediately obvious what it tells us. And so in this video, I would like to tease out, what that really means to talk about the direction of the acceleration. What we're going to do is we're going to combine the direction of the acceleration with different directions for the velocity and see how that affects the motion of the moving man that you saw in the previous video. And then as we determine what happens with the moving man, we'll record it and try to figure out what the pattern might be, what the direction of the acceleration really communicates about an object's motion. Let's go ahead and start off with the moving man over here on the left. We are going to give him a positive 5 meters per second velocity, which is represented by the red arrow, and that means he's moving to the right. And if his velocity were to continue at a constant velocity, his displacement would change by 5 meters for every second. But this is really going to be an instantaneous velocity. This is going to be the velocity at the beginning because we're going to give him an acceleration. And that means his velocity will change, right? So this is really just going to be the starting velocity, the initial velocity, an instantaneous velocity. I'm going to give him a 1 meter per second squared acceleration. And this 1 meter per second squared acceleration is going to be positive. And keep in mind what 1 meter per second squared means. Remember, that's a condensed unit. We could talk about 1 meter per second instead. So that means the velocity should change by 1 meter per second for every second the man is traveling. Now you'll notice a green arrow has shown up on the screen. That green arrow represents the direction of the acceleration. And remember, acceleration is a vector, so it's being represented here as an arrow, where the size of the arrow tells us something about the amount of the acceleration, and the direction tells us the direction of the acceleration. I'm going to hit play, and your job is to simply watch what happens. Now, what did you notice? Yeah, you should have noticed that the velocity increased all the way across. The moving man was speeding up when he had a positive acceleration combined with a positive velocity. Let's go ahead and record that down. Again, keep track of what's happening. So I have this chart here in which I have the direction of the velocity up here in 2 columns and the direction of the acceleration right here in 2 rows. So in each part of this chart, we're going to fill in what kind of motion we're observing for the different combination of velocity and accelerations in terms of their direction. So for positive velocity and positive acceleration, we saw the moving man do what? That's right, we saw him speeding up. He got faster and faster. So I'm going to write speeding up here. So with a positive velocity and positive acceleration, the object got faster. So now let's take a look at a different combination. So we're going to keep the positive velocity involved, so you're still going to move to the right. But what if we change this acceleration to be negative? If the acceleration is negative, what should happen to the green arrow? That's right, it will point to the left. So our acceleration points to the left. Our velocity points to the right. Now let's see what happens in this combination. So notice how the man slowed down with that combination of velocity and acceleration direction. Let's go ahead and record that information. So we saw with a positive velocity and negative acceleration, an object slows down. So we're going to write that in here in this chart. Now let's take a look at a different combination. Let's start looking at some negative velocities. and how pairing up different direction accelerations affects an object's motion. For this scenario, I have the velocity now at -5 meters per second. Notice how I've placed the moving man on the other side of things. Well, that's because with a negative velocity, he's going to be moving to the left. And if I were to keep him over here by the tree, and he was moving to the left, he would just move off the screen. We wouldn't be able to see what's going on. So I have the moving man now in this location over here next to the house, and we're going to have a negative velocity with a positive acceleration. So the direction of the acceleration is positive. You can see that with the green arrow. And the direction of the velocity is negative. You can see that with the red arrow. Let's go ahead and see what happens. Interesting. So with that combination, a negative velocity and a positive acceleration, the man did what? That's right, he slowed down. Let's go ahead and record that in our chart. So here's our chart again. Remember, the purpose of this chart is to look for patterns. So right now, we're going to write down what we saw for a negative velocity and positive acceleration. Again, we saw the object, in this case the man, slow down. So we're going to write down slows down. All right, so we've got one final combination to look at. What happens to the motion of an object when you have a negative velocity and negative acceleration. So we're going to take a look at that next. I now have the man move back to the location over here by the house. I've given him a -5 meter per second velocity, so the red arrow points to the left. And I have a -1 meter per second squared acceleration. So now we're going to see what happens to the motion of the man in this scenario. Go ahead and watch. You should have seen, as he went across the screen, that red arrow is getting bigger and bigger, which means he was getting faster and faster. He was speeding up with the negative acceleration and negative velocity. We're going to write that down in our chart, but before I move on, I want you to notice something important. Every single example we looked at, the moving man moved in the direction of the velocity. So if we had a negative velocity, he moved to the left. A positive velocity, he moved to the right. Notice how his direction of motion didn't necessarily match up with the direction of the acceleration. That's just something that's important to know. So the moral of the story is the direction of the acceleration does not by itself tell you which way the man is going to move. Only the direction of the velocity will tell you which way the man will move for sure. Let's go ahead and record in our chart what we saw for the negative velocity and negative acceleration. Okay, so we saw with a negative velocity and negative acceleration that an object will be speeding up with that combination. So I'm going to write that in over here. Can you see the pattern now? Take a look at the chart carefully. Look at both speeding up scenarios. Notice how in either the speeding up scenario in the portion here or the speeding up scenario in the portion down here, the sign of the acceleration and velocity match. So we have a positive velocity and positive acceleration for this speeding up scenario and a negative velocity and negative acceleration for the other speeding up scenario. So that tells you that whenever the direction of the velocity and acceleration match, you will get a speeding up situation. The object will get faster as a result. On the other hand, objects will slow down when the direction of the velocity and the direction of the acceleration are opposite of one another. So if I have a positive velocity and a negative acceleration, an object will slow down. If I have a negative velocity and a positive acceleration, an object will slow down. So this is pretty powerful to know because it allows us to predict what the motion will be for an object, especially if we know the direction of both of those motion variables, the velocity and acceleration, or if we know an object is speeding up, and you know the direction of one of the variables, you then can deduce what the direction of the other variable would be by knowing this pattern. So let's go ahead and get this in our notes. So as a summary, when the velocity and acceleration have the same direction, objects become faster. When the velocity and acceleration have opposite directions, objects become slower. You will definitely want to get this in your notes because we will be using this principle quite often to determine things about objects that are in motion. That's all I have for the video today. Let me know if you have any questions, and stay classy.